Hi guys, welcome to our experiment. This is chemical experimental science made by Miranda, Mayte, Majo, and me, Saemi. And in one of our daily talks, we talked about cleaning products, and we wondered about this lemon and detergent cleaning method, and we wanted to discover what was behind all this. So we discovered acid-base reactions, and this may sound a little bit confusing, but at the end of the video, I'm sure you will understand it perfectly. After checking many documents, we found out this experiment of making an acid solution to a base. So our experiment is to add baking soda, acting like a base, to vinegar, like the acid, in a plastic bottle with a balloon on top to see how the balloon inflates. With this experiment, we will determine how the size of a balloon increases when more baking soda is added to the vinegar. We thought about what the reactions could be, and we said that if the amount of baking soda increases, then the size of a balloon will also increase, because acid-base reactions produce carbon dioxide, and the more baking soda is added, then the more carbon dioxide is produced, so the balloon will have more gas inside it. So let us show how we did the experiment.
So when we started this experiment about mixing baking soda with vinegar, what we did is each of us did a separate amount of baking soda. One of us did 10 grams of baking soda. The second one did 20 grams of baking soda. The third one did 30 grams of baking soda, and the fourth one did 40 grams of baking soda. And after the reaction was over, we all measured the circumference of our balloons with a measuring tape.
We had 4 experimental groups in which we used different amounts of baking soda.
This is the first raw data table that we used to collect our data for the experiment from. Each of us used a separate table for each measurement of baking soda. As you can see, it has a space for the circumference of a balloon of each trial, and it shows all of our control variables. The milliliters of vinegar, the category of vinegar, the size of the bottle, the material of the bottle, and the balloon material. The second raw data table that we used is basically the exact same, except it omits our control variables. Throughout the experiment, we tried to the best of our ability to keep all of our control variables shown on screen right now the exact same so that none of them would affect our dependent variable.
In the first group, we used 10 grams. In the second group, we used 20 grams. In the third one, we used 30 grams. And in the fourth one, we used 40 grams. In each group, we kept the balloon material, the size of the bottle material, the type, and the amount of vinegar the same. And also, we realized 3 trials for each experiment. In the 10 grams group, in the first trial, the circumference of the balloon was of 46.5 centimeters. In the second trial, the circumference was of 45 centimeters, and in the first one, the circumference was of 46 centimeters, with an average of 45.8 centimeters and a standard deviation of 0.78 centimeters. In the 20 grams group, in the first trial, the circumference of the balloon was of 48.5 centimeters. In the second trial, the size was of 47.8 centimeters. And in the third one, the circumference was of 48.8 centimeters, with an average of 48.3 centimeters and a standard deviation of 0.51 centimeters. In the 30 grams group, in the first trial, the circumference was of 46 centimeters. In the second trial, the circumference was of 47 centimeters, and in the third one, the circumference was of 46 centimeters, with an average of 46.3 centimeters and a standard deviation of 0.58 centimeters. Finally, in the 40 grams group, in the first trial, the circumference was of 55 centimeters. In the second trial, the circumference was of 54 centimeters, and in the third one, the circumference was of 56 centimeters, with an average of 55 centimeters and a standard deviation of 1 centimeter. Finally, we made a graph based on these results, having the baking soda as the independent variable and the average of the circumference of the balloon as the dependent variable. Therefore, the bar shows the different amounts of baking soda that affect the circumference of the balloon, starting with the 10 grams group until the 40 grams group. Overall, the size of the balloon increases as more baking soda is used, because the trend line from the 10 grams group to the 20 grams group increased, even if the trend decreased from the 20 grams group to the 30 grams group. Again, the line increased from the 30 grams group to the 40 grams group.
With this graph and our results, we can conclude that our initial hypothesis, if the amount of the baking soda increases, then the size of the balloon will also increase, because acid-base reactions produce CO2, and the more baking soda is added, the more carbon dioxide is produced, meaning there will be more gas for the balloon to be inflated with. Is that correct to a certain extent?
So what is actually happening here? In order for you to understand the reason behind our results and why this is happening, we have to explain two different things to you. The first one is the law of conservation of mass, which basically states that matter cannot be created nor destroyed. It can only be transformed. So when we mix the matter from the baking soda with the matter of the vinegar and it produces carbon dioxide, this doesn't mean that carbon dioxide is just appearing out of thin air. It means that the matter from the baking soda and the matter from the vinegar have reacted together and transformed the matter into three separate substances, one of them being a gas, which is carbon dioxide, the second one being a salt, which is diluted into a liquid, and the third one is water, which is a liquid. And this is where the second thing that I have to explain to you comes in: acid-base reactions. So when we mix an acid with a base, it transforms into salt and water. However, in this specific reaction, a third substance is produced, which is carbon dioxide. So the chemical equation for this reaction is C2H4O2, which is acetic acid known as vinegar, plus NaHCO3, which is sodium bicarbonate known as baking soda. It transforms into NaC2H3O2, which is sodium acetate, which is a type of salt, plus H2O, which is water, plus CO2, which is carbon dioxide. So what is actually happening in this reaction is that when you mix the baking soda, which has an oxygen atom, a hydrogen atom, a sodium atom, and a carbon dioxide molecule, with vinegar, which has a hydrogen atom and an acetate ion, a bunch of chemical reactions start happening. Firstly, when the acetate ion mixes with the sodium atom, a salt is formed, known as the sodium acetate. Then, hydrogen and oxygen also mix to produce H2O, which is water. And then finally, the carbon dioxide molecule doesn't react with any other molecules and is liberated as its own. So in our experiment, the more baking soda you add to the vinegar, the more molecules within the substances there will be to react with each other. Therefore, more carbon dioxide will be produced.
There was definitely room for error throughout our experiment, as there is with every experiment done. Throughout the results, we can see that our results for the circumference of the balloon based on the 30 grams of baking soda is an anomalous result. As in the graph, there is a clear spot in the constant growth within the previous results, that is later picked back up at the last measurement. At the same time, we did not all use the same vinegar brand, which could have potentially caused some trouble with the experiment too. If any of these factors did actually affect the results that we got during this experiment, it could mean that our results aren't as reliable as they could be, and our conclusion would not be supported by a concrete evidence.
We hope you've enjoyed our experiment and hopefully you learned something new. Thank you for listening.